Ich habe tatsächlich ins Lido-Link dann dieses Ding reingehauen.
So, das ist so. Ja, so oder so.
Machst du ein letztes Lido weg? Jetzt bei den Teams oder? Ja, genau, da ist vorher das Announcement, das da. Und da kann ich die Fragen schicken. Das ist die gehighlightete Karte. Ja, genau. Also die so aktuell ist, das ist die aufschiebbar war. Muss die oben sein? Das ist gut. Highly professional.
Aber wenn es da passiert ist, das sieht man sowieso, oder?
Okay.
Ja, das würde dann.
Okay, kannst du bei Slido dann einstellen, dass wir für Luca und für die kroatischen Kollegen so einen Admin-Account nehmen, dass die dann ihre Fragen noch bearbeiten können?
Ja.
Oder Betrieb oder für irgendjemand?
Du willst es eigentlich gleich dabei machen, oder?
Ja?
Nein, ich behalte es. Wo ist er eigentlich?
Was? Das Hotel wahrscheinlich, hat er gesagt.
Ah,
Frag mich was einfach über.
Oh, mir wurscht.
Ja.
Ja, wir schon etwas erwartet.
Beziehungsweise haben wir schon einen Teams-Link aufgesetzt, den man dann dort aufmachen kann, wenn es Fragen zu weitergeht.
Ja.
Gibt es schon?
Was nicht?
Weißt du das? Was? Für die kroatischen Kollegen. Haben wir schon Teams-Link für die Session der nächsten Stunde?
Wir haben das über Google Meet gemacht.
Und das funktioniert schon?
Das funktioniert, ja.
Okay, passt.
Also Woche geht jetzt Google Meet rein und du ziehst für.
Mhm.
Und in Google Meet haben wir auch einen schönen Vorbild. Also so gut wie der Google Meet geht. Ja, genau.
Und das habt mit dem Link habt schon gut verschickt.
Ja, wir haben mit denen konzentriert, dass mit denen alles ab.
So, ich habe jetzt 2 Leute ostnational gehabt, so
Nee?
den Luca und die Petra.
Okay.
Ja, das Kommilitonen geschickt haben.
Ja.
Bist du ready? Du kannst mal einschicken, also solange wir auf
Ja, sind wir auch gelaufen.
Das ist das Pausenzeichen, das haben wir gemietet.
Sicher?
Probier's.
Nach mal die Präsentation. Das ist schon die, was ich dir geschickt habe, oder? Mit dem richtigen Punkt.
Du musst ja trotzdem umschalten auf den Bildschirm.
Ist das wieder Blöder? Nein, das ist nicht. Kann man das nur verbinden, dass es nachher der Blöder kann?
Jetzt 1, 2. Ja, nicht, ja. Okay, hello everybody. I will do the next part about related electric scrutineering. And I will also go a little bit on data. Let's start. As the talk before, at my end is the same. There are some quite good presentations from FSG. You can find them on the FSG website. For rules after FSG rules tool, and also very important competition output. Always some small differences you have to know. A short overview, I will give you some tips for e-scrutineering. They are quite similar to the next scrutineering tips. talk a little bit about why scrutineers are so strict. I will talk a little bit about accumulator design, and last but not least, how to pass rate test. Yeah, tips for e-scrutineering. In the design phase, read and understand the rules. It sounds obvious, but always talk with people. They start designing something during design process or during the manufacturing process. They realize, oh no, that's not rules compliant. The worst thing is if they realize at the event that it's not rules compliant. So if everything goes wrong, but always read the rules. And if you're designing one special part and only one part, don't read only this one part. So if when you, for example, design the PSPD, do not only work with the PSPD rules. There are links to other parts. You have to understand this. You have to understand these rules. So normally it's not enough if you just read exactly this rule. You have to read the context. You have to read everything. Yeah. The next thing is keep it simple and stupid, keep it small and simple. I also do ESF review, and there are always IC schematics where, yeah, it's very fancy stuff, very good stuff. I'm always surprised how complicated you can build up a flip-flop. So for a student background, it's normally much better you buy one because you can buy them at Mauser, well, it's just one chip and everything's done. You can build it up by scratch, you can build it up at home. That's cheaper, maybe that's not smaller. Yeah, keep it simple. The most fancy solution is not very often the best solution. Sometimes, yeah, but not very often. And also, easier to maintain means easier to fix. You're building a race car, you're building a prototype. It's normal that your car will break during testing. That's the reason you go testing. If you have very complicated parts, if you have very complicated tools, if the whole car is built very fancy, and it's very hard to dismount some stuff, you need quite a long time to fix this. So normally a race car you should dismantle completely in a few minutes, less than 1 hour. Yeah, after design phase, before the event, so when you have built up your car, as Dr. already said, know your inspection sheet by heart. So train your scrutineering. Normally you have your scrutineering team, so 4 people that are allowed as scrutineering. Together, train these people. This can be other team members, alumni, this can be other teams, and as already the Q&A said, other scrutineers. So some of them are private with B or something I heard, I don't know. If you have a scrutineer in your area, ask them to have a visit at your workshop to see your car. Invite other teams or invite alumni of other team because you have very often a blind spot about your car. So your whole team is absolutely fine with this solution because it's the best solution, it's not rules compliant, and then you have one external guy that is, the first thing is, yeah, why is this like this? It's not the best solution, it's not rules compliant, you have to look at it. So always, it's good to have other guys see your car. Yeah. Inspection sheet, copy already showed on the homepage. It's on our homepage, it's on the FS4A homepage, it's on normally on the Netherlands homepage also. It's not secret. Just use an old version, old inspector sheet is always much better than no inspector sheet. And don't do your test scrutineering once and okay, you have the finding and everything. Do it ever and ever again until these 4 guys who will be the scrutineering at the event already know what to do, what is the next step. The next thing what I can recommend extremely is go to pre-events. There are the VD events, there are the racing camp, FS Easter, and some others. Go to at least one of these. Normally, you find the scrutineer from FSG, from FSA, from FS Easter, from other events. And you have already the racing spirit, the event feeling. When I'm at a pre-event, I normally ask the teams would they like a fast scrutineering, they can go on a track as soon as possible, or would they like to get the hard scrutineering that I look at every part and to find as much as possible to prepare them for the events. Most teams say they want the hard scrutineering at the pre-event. If you fail this event, it still means you can drive your car, that's not the problem. But you have a list with issues you should fix to the events. And the next thing is testing. Test your car, go on the test track. You have teasing problems, you have something will break, this should break at your test track and not at scrutineering, or not at the brake test. So if your first time, if your car is first time hard braking during the brake test, then you may not wonder if some suspension part is broken afterwards. At the event, have your stuff together. Most time is lost because the scrutineer wants to see something, and the team, oh yes, this is the pit. I have to go in. Or I want to see something in the car. Yeah, we have in the tool. This tool is in the pit. Here you lose very much time. Or you have to search for it in your boxes because you bring. It seems a little bit strange because you bring very much boxes, but the tools you need are not with you. You search for them. Have your spare parts and spare PCBs with you. Scrutineer want to see them, especially in the first scrutineering. And also bring necessary tools and equipment. I say it's not always that you need a wrench or something. Have more than one guy that knows everything. It's sometimes interesting at scrutineering. We have 2 or 3 scrutineers. We want to test something, and there's one guy from the team that's the head ESO or something like this that know exactly what has to be done next. And then 2 or 3 other guys, and they know how to bring something when they are asked. So they normally, at good teams, you see them, they try to split up the scrutineer, so start at another part of the scrutineering sheet, because you don't have to do the scrutineering sheet step by step. You can start at the other end, you can split it. The only thing you can't do is low voltage testing and high voltage testing, but this is another topic. And then the pro tips, always be fully prepared in the power cells between the slots before the slots. So we have a slot system in FS Austria. You know when the slot will end. Normally the slots are published, so main team will be starting. If you know, for example, that one team is a no-show, You can ask us beforehand, we will check it, but it's normally much faster than we wait for a team that will not come and we are waiting. And as soon as we say, okay, this scrutineering bit is now open, then we can open this bit for repair and re-inspection, and that helps you, even if you're not the first in line, and if another team will be the re-inspection before you, but if they are fast, then you also get it. You have about 90 minutes for this re-inspection slot, and normally there's enough for 2 or 3 teams. Also, changing slots is permitted. Both teams agree. So if you find another team that has a very early slot and say, yeah, we are not fully prepared and will not be possible to start here, and we want to change with the team that they have a later slot, and I've heard there's some fear about this. As long as both teams agree, we don't have any problems when they change the slot. Yeah. Why are e-scooters so strict? I sometimes heard that, it can be the problem is current is dangerous. Motorsport is dangerous, yes, but current is dangerous on another level. The line we draw is at 60 volts, and yes, 60 volts are theoretically dangerous. So I've never had a problem when I touched the line with 70 volts. Yeah, that's not the problem. But at 60 volts, it starts, and it's not a hard fact. It's not a hard border, a hard line. If you cross it, you will be dead. No, that's not the line. But 60 volts is the border, the line by the law, and it's the line by the rules, and that's the reason we enforce this 60 volts. If we wind it, then the next team wants to start with 32 volts, then 85 volts, then maybe 100 volts, and yes, earlier we are at 40 volts because 400 volts because as Mark, if you feel 100 volt DC, that's not so easy anymore. Also, the next problem is the internal resistance of the LiPo cell is virtually not in existence. If you have a ring, a metal ring or something like this, and you shorten these 2 poles of only one cell, your ring will melt immediately. So that's the reason we don't say no too early or something like this in the accumulator. Also, burning accumulators are very hard to extinguish. Everybody knows this. LiPos are LiPos. They have a very bad reputation, mostly because when they are burning, they are burning. Then you just wait till it's done, and everything that's surrounding them is also burned. So we don't want to have this. So,
So, at this point, I realized that me and Eugen, we have not told you who we are. So, I am Paul, also known as Boki. I am the head of mechanical scrutineering at FS Austria, and this is Eugen. He's the head of electrical scrutineering at FS Austria. So, sorry for not saying hi before. Better late than never. And in the last session, we're going to have colleagues from FS4A presenting how to run statics. So now I have another few slides for you. So for everybody who hasn't seen enough of my magnificent Styrian hats, here we go again. Best practices with regards to tractive system enclosures. So tractive system enclosure is not only the tractive system accumulator container, but also your inverter box, remote controller box, whatever, everything where high voltage is inside. You need to have a 0.5 millimeter grounded aluminum layer. If you have some kind of material which is neither fully conductive nor non-conductive. So if you have like a carbon fiber laminate, you need additional aluminium layer. Or if you have like a laminate with aluminium honeycomb, you also need that additional layer. So my good tip for you is take the easy route. Either you have a enclosure which is made of only non-conductive material all throughout. So, for example, in top picture, this is a aramid fiber laminate with non-conductive core inside. So either a foam core or balsa wood or also Nomex honeycomb core works as well. Or the second option in the second picture is make it aluminium throughout. You need aluminium layer anyway, if it's not fully non-conductive, so just make the whole thing out of aluminium. And then, of course, on the inside you need some kind of insulating area. For that, the standard material is the carbon tape. This works really well. And then the next thing is how to make a box for electronics. We've seen in the past that the guys who are tasked with making the accumulator, they're very interested in getting the packaging right, getting the EMS system right, all of the electrical stuff, and then in the end they figure, we also need some mechanical stuff in order to make it work. So here are some good tips from us on how to make it easy. Step 1. Laser and water jet cutters are your friend. Make design using key and trunk features. So this is depicted as an example here on the right. You have sheet metal, or also works with foam core with the parts sticking out, and you have holes in the respective parts where that slots together. So this makes it very easy to fit everything together, and then you either bond it together or you weld it, but this is really makes the whole process easier. This will also work for laminates if you take a foam core, for example, and you stabilize that foam core with a very thin, for example, glass fiber laminate, so there's like 0.1 millimeters thickness, and then it's already much more stable, the core material, and then you can cut it as well, slot it together with a glue, and then afterwards you make a wet lamination process and add all the rest of the fiber material. Also, one very important topic with regards to enclosures, you are allowed to have ventilation holes. But new rule for 2024, these ventilation holes must not be larger than 25% of the respective surface. So for example, see here that side wall, this area maximum 25% of it must be a ventilation hole. And for ventilation holes, please apply good engineering practice, because the wall still has to take mechanical loads. And if you make lots of slots into it, like in this ventilation break, then it might be good for ventilation, but it's not good anymore for load transfer. So that is not a good engineering practice. Make round holes which can redistribute the forces. And if in doubt, please come to us and give us a question how to do it. Next slide, best practices how to attach pouch cells. So pouch cells in accumulators are of course a very attractive option because they have a high energy density, but they are quite difficult to handle, especially if you have to apply like the 40 T load phase for attaching the cells. And there is now the EV 5.5.9 rule. Your pouch cells must be fixed using 80% of at least one large surface area. The large surface area is of course the side, which is the largest side, and you have two options. Either you can bond it on one side, so this is option 1. You are allowed to bond it only on one side, that is acceptable. So here, of course, red is the bonding adhesive, and blue is the accumulated spec frame. And the option 2, which we would say is even better, that you have some kind of high friction but still compressible material, which is here in orange. You stack it between your pouch cells, and then you clamp it all together inside of your stack. So that is totally fine for the pouch cells. Most of the cells even quote unquote like it if they are slightly pressed and held together. And that is how it's done. You must never make it so that like the small end area here or at the top where the terminals go out, this must never be the attachment point for the cell. It must always be through the large surface area. Next slide, best practices with regards to cylindrical cell attachments. So cylindrical cells are mechanically much more stable, so they are easier to work with. And the only tip I have here is, again, laser and water jet couplers diaphragm. Use that to cut from any type of material which is already UL94 rated. And in order to make your life easier, don't use 3D printed materials, because you will have much more questions to be answered if that material is indeed fire resistant. Because, of course, there are 3D printed materials which are according to the rules, but you have to show at Scrutineering that the way that you printed your distinctive part is indeed correct to that specification. That will not happen if you have standard plate material, because you don't have something like the filling grade of your printer as a variable. Then the next part of the whole load case. So you have to consider your load case with the 40 and 20G, starting from your cell, going into your cell stack. So that is what the last two slides was about. The next step in the load case is getting the force from the cell stack into the accumulator housing. And the most solutions have like an accumulator which is like a box with a cover on top. And for the longitudinal and lateral forces, it's really easy to transfer it because you have direct contact. The cell stack here in green just pushes on the whole surface area towards the front and the sides. So that's it. The problems always start with the vertical load case. And many teams want to use the accumulator cover as a mechanical device. But if you do that, you have to make sure that this flat plate is actually up to the job. So in most cases, you will need to actually make it much more thicker than the minimum material requirement. And also, in order to make it work, you need a spacer here in between that can actually transfer the forces. So my tip to you, don't do that. Use the cover just as a cover to seal up the box, and bolt the cell stack frame directly to your internal walls. You won't need more than 4 bolts, and in most cases, like M6 bolt is completely fine, maybe even smaller. And then you don't need any kind of spacer in between anymore. Your cover will work just fine, and it's just much easier overall as a mechanical solution. Yeah. And then, of course, the last step of the load case is how to get forces from the accumulator into the chassis. And for that, I also would advise you, if you're working with sheet metal, so either aluminium or steel, make the cutout of your sheet metal with integral attachment points. So here you can see the floor, which is in black. It has like a protrusion here in the front with the bolt hole already, and it also has like the gussets integrated in the cutout, and then we just bend it up and weld it all together. That is very integrated and very good load transfer through the original material. If you go for bonding something, that is of course acceptable, but there is a lot more steps that you have to follow. First thing is you have to adhere to rule T328. You have to use a 50% reduction in the strength of your adhesive. Then the next challenge is that you have to make sure that the whole bonded surface actually has adhesion. And then the third thing is, like here in the crossed out example, this is not potential in practice because this bracket is not secured against peeling off. So if you have here like forces pushing on the bracket, there will be stress concentrations at the corner of the bonded surface, and it will start peeling off from there. So if you do that, you need to have like additional reinforcements, like here on the right side, which secure against peeling off. And then last thing, work together with your chassis department in order to make sure that the loads that you put into the chassis are actually being handled correctly. And now I give back to Ryan.
Yeah. That was the mechanical part of the validator pack. Now the electrical part. There's not so much electrical difficult parts in the accumulator because as soon as you connect the boost bars, you weld them together, you screw them together. There are different solutions, some better, some worse, but yeah, that's not the big deal. The most problem I saw was with the maintenance plugs. Teams try to construct their own somehow maintenance plugs, and it's much better if you just buy them. So from Amphenol, the Surlog series, quite simple. There are different sizes, different shapes. Normally you find a good solution for your pack. There are also other manufacturers, but most of them are connected somehow. So yeah, you fulfill the rules quite easily. You have finger rules. Yeah, that's normally the way to go, especially when you design your first accumulator pack. Just buy the maintenance plugs. That's fine. Good. Yeah. The next thing is the BMS. BMS is a little bit harder because with the new rules, there's nearly no bound BMS as rules apply. I had a little bit of research to find some. I didn't find one, maybe you have one. The best solution I found was Fog BMS. It's an open source BMS. It's quite big, quite strong. You have to tailor it to your needs. Everything together, I think it's easier to build the BMS from scratch. There are now tricks from NXP and from analog devices. They are quite similar. And within the tricks, you find the application notes, how to build them, and according to some teams, they say this works. This application schematics you find in the data sheet, or in the data sheet, they are working, and yeah, build it like this. Then you only have to build a controller, some STM microcontroller, or something you prefer. You can even use Arduino or something like this. Would not be my choice, but possible. Yeah, and this would be also going to an open source project together. Maybe some teams can find together to make a little bit some kind of open source project. Maybe tailor make a fork on the Fox BMS project to tailor this for the student, because everybody needs practically the same. There's practically no need that every team make their own BMS. And it's not so hard, and it would be easy to make it open source to squeeze the load, especially for first year teams or teams that switch from combustion to electro. Accumulator and weight test. That's not very last story. We have every year much more than one team that has troubles with weight test. This means normally water inside the accumulator. That's a big issue. So when you have weight test after a few minutes, less than 4 minutes practically, the IMP light starts lighting, and then we have a problem because we have to find this error. Normally the accumulator will be disconnected, then you can remove quite easily the accumulator or the car. If it's the car, it's not a big problem. If it's in the accumulator, that is a problem. And we had an issue last year in FS4A. One team had water in the accumulator, and they had additionally voltage on the connector. That was a little bit strange, but yeah, so they had very much water in the container at different position, and it was and in this case, if this happened to you, then you have to bring the accumulator in the accumulator tent, measure the voltage between the practice system and the housing, then you open the maintenance plugs, then again you measure the voltage between the practice system or the stacks and the housing, remove the stacks, find the error, because normally you have an isolation error, and so on. Consider you have to do this, especially till the moment the maintenance plugs are open, everything with full gear. So when you design a maintenance plugs, to go back to the folio I had before, decide or use maintenance plugs we can easily remove. Also, you can the stacks remove. So I'm here a little bit different opinion than Rocky. I think it's not the best solution to screw them at the bottom of the container, because then you have a problem. You want to dismantle the container easily, and you don't want to touch inside the container and work inside the container. That's not the best top-life balance. After this, you have to dry everything with towels, with heat guns, everything. Your teams are very creative to dry everything. Rebuild your container, seal it, and then we dry wind test, and hope it will be better. And for the teams that not have been in Austria or not have been last year, 2023 in Austria, the wind test is to simulate wind. And every event has a different wind test. In my opinion, that's very good, because wind is not always the same. And I think at every wind test, some water comes from the boat. That's normal, that's wind. And everything else, it's a little bit different. So in FS3, it's weight from the tires or to the tires. In FS4A, we put some rain from behind, and this was the accumulator killer a few years ago, because we had a little bit difficulties with the Red Bull ring, which sometimes got water with very much pressure and sometimes got water with not very much pressure. That changed every year, and we didn't know it before, and so on. Since last year we have a pressure regulator, so it doesn't care what kind of water we get. And it's a nice and smooth rain test now. There should be not a problem anymore. Should be. We had last year three or four cars with water in the accumulator, so should be. Yeah, design your chassis weekends with that range from above. It's not enough to seal to water tighten your accumulator and your boxes because something happens. Something somewhere happens. It's quite important to have your whole chassis waterproof, watertight. You can, at the design of the chassis, you can start thinking about how can get water here inside the engine compartment, the accumulator compartment. How can we build this? Maybe another way that water will run outside and not inside. Also, you should see all your tracker system components, housings, and also the tracker system container. About sealing the container, you always have the problem with ventilation, especially when it's air-cooled, and waterproofness. You just have to think about how the air will go from outside into the container and what you can do that it will not suck any air from exact this position. So, yeah, it's not a good idea to suck the air from the car floor inside the accumulator because, yeah, you don't want to have dirt from the street inside your accumulator. Yeah. Also, every few years, some teams try to tape their car, everything, tape them. It's getting better than last year, but always some teams are trying to, yeah. In my opinion, it's very bad engineering practice. It's just you should design a car that is able to run in rain. And then you have a problem with 2 minutes water from above. That's not, then you didn't reach one of your design goals. Taping your car at the rain test is practically forbidden. All tape that is added to your car before the rain test to water tighten your chassis will be sealed with stickers from our side. And if you remove these seals, then you have to redo the rain test. So that's a problem because on Thursday there is no rain test anymore possible. So from the Tuesday in the afternoon onwards, you are not able to open very much parts of your cars anymore. So think if this is really a good idea, or would it be a better idea to fix this stuff in the design phase? Yeah. That's everything from my side. Yeah. I move for questions of Q&A.
Yeah, okay. Yeah.
Wir haben gerade keinen Ton.
So thanks for your presentation. So starting with the first question. Also for batteries, we have seen numerous incidents and breaches back in the past 2 years. do you need some kind of standardization to improve safety?
Hard question. Yes, I personally think so, but we are a defined competition. And as Hockey said, it's not enough to put the games on Lego. It should be also be a design competition. And if you say, okay, we have to standardize the accumulator and everybody has to use exactly this accumulator, I think we lose very, very much from the electric vehicle, from the student part, and so this will not happen.
So next topic, some tips and tricks for an EMI concept.
Oh yeah, EMI. That's also very hard to answer because EMIs, you do one thing and at one car it works fine, it works good, everything's fine, everything's happy. At the next car, yeah, it doesn't work at all and make everything worse. To have a good EMI concept is always you have to.
Maybe I interrupt here. Obviously, in Germany already had this topic at their academy, and you can find the dedicated presentation at their site.
Yeah, and it was a quite long discussion there also.
Okay, so can you tell us more about system critical signals? How should we follow a path? What should we do? Etc.
Yeah, critical signal is a definition from the rules. I don't know if I understand the question correctly because there is quite directly defined how you have to handle system critical signals. So there are how should you follow a path? Just by designing your own PCBs when you send out a critical signal, and when you receive a critical signal, you have to make schematic parts or input circuits that can handle this, that can detect stuck to ground, analog signal stuck to high, stuck to low, and so on. But yeah, just read the rules.
Okay, good advice. Thanks. So next question about PCB requirements. Basically HCM for installation, segments, configuration, cooling, first battery bank.
What is the question?
I think I need some tips from you about designing the first battery bank.
Yeah. About wavelength, yeah. For the rules, there is no limitation. There's just some engineering practice. You should make them as short as possible and make them as long as you need them. So, yeah, space between HY and LY, there are spacing is written in the rule, how much you have to have between HY and LY. If you use coating, then you can use smaller spacing. Yeah. And for different parts of the HY system, if you want to have them, you can also use the spacing that is in the rules. That's not so bad.
Okay. Next question about lithium cells. Manufacturer only provides maximum current. What sort of peaks, charging, discharging current are acceptable for the competition?
Most manufacturers also provide maximum currents. So you have 2C for continuous and 4C for a few seconds. It can be from milliseconds to 2 seconds. You have to contact the manufacturer if it's not in the data sheet you got. contact the manufacturer, ask for exactly these values. Most of them give you the values, give you a data sheet with these values.
So, can the BMS and the low voltage parts of the DCAC be placed above the SES in the side view of the VQ?
Whoa. Make a good question.
Okay,
Make a good
we
question.
put them on hold. Really good question.
Yeah.
So, next question, what key part of the low voltage system do you look at?
At Scrutineering, we only look at the ESPE, at the T-cell, in this case at the low voltage part of the T-cell, but we look at the whole T-cell. Also on the latching a little bit, mostly in the ESF. And what we really have a big look at is the shuttle circuit. So basically everything that is connected to the shuttle circuit, we will have a look at.
Okay, thank you. So starting a bit more about the mechanical part. What are some good practices for mechanically separating the tractor system and the LVS cable within a tractor system enclosure? Have you seen any common mistakes?
No, I don't have seen any common mistakes, to be honest. Yeah, some, yeah, but no, nothing common. Mostly is that some that much teams forget about this rule, especially if you put two systems together and then you can't have this spacing anymore because when you open it, then it looks fine. And as soon as you close it, then it's not visible anymore. But yeah, mechanical use zip ties. Just fix the TS and the LVS cables on some walls or do some kind of
Use common cable.
Yeah, just zip ties. Zip ties and normal cable models.
Okay, a question to Rule EV515. Is it still needed to add a vertical wall if each segment has its own facing, which fulfills the rule's requirement?
Yes, you need an internal wall which is integral to your traffic system accumulated container in order to have a mechanical separation which can take the load. So your cell stack might have like a proper cover around itself as well, but then the cell stack needs to have a boundary where it can push against, that is the internal wall. And also this external wall is also there for fire safety basically and insulation. So that's definitely needed there.
So can a tap washer be used as a locking mechanism for the airs? There are different options as we went, and we have to change it several times.
Okay, yes, it is allowed to use a tap washer. It has to be done correct. It's not good to hear that you have different options, different opinions. I don't know how now by heart how you should use it. It's always it's always I have to see it, but yeah, it is possible, and it's not so problem. The only thing is it has to be done. It has to be well done, and when I correctly remember one of the solutions I had out after last year, it was not done very good, and then the first scrutineer said, yeah, it's okay, the second said, no, it's not okay, that was not how it should work, but
Okay. What are the best ways to ensure the watertight plastic system enclosure?
I already answered.
yeah,
Okay.
yeah, keep opening, yeah, that's
So we had that answers in the presentation. We jump to the next question.
nothing to it here.
So let's go further with which insulating materials for internal walls are holes allowed in the internal wall for air cooling? If yes, which size and pattern?
I think nowadays, so it must be at least 7% from the bottom upwards, as far as I know, and the 25% rule applies also for the neighboring, as far as I know.
Basically, internal walls have pretty much the same requirements as external walls. And for insulating, as you said, Kapton is a really good material for that because it's well insulating but also mechanically quite strong.
Okay. So an interesting question about the factory policy. How can you solve the new requirement for the factory policy to have a transparent firewall?
Yeah, quite simple. The Macolon, it don't have to be a firewall according to rule T something, but a firewall is defined for electrical vehicles. It don't have a firewall like this. It's okay to have some fire retardant material to have the UL424 or something like this. UL94 according to the rules. And you can use the whole blade from Macolon or some other stuff that you can see through and is a firewall.
Okay. Does the AMS comply with EV 5.8.3 and EV 5.8.12 rules when it shows only two temperature values, the minimum and the maximum? All other cell temperatures not displayed.
I don't know exactly these rules, but I think I know what's the meaning about it. No, it's not okay. This was also the FSG question, and they clearly say no and why not.
So let's keep another two questions. Is it worth it to manufacture the PCAC out of CFRP? Or will the mass saving not be worth the additional cost instead of making it out of aluminum?
I will say you're the engineer, to be honest. You should know this. To be honest, yeah, as already answered in the presentation, it depends on your own resources. In my opinion, aluminum container would be better because I would always do some shielding in my container to shield my container to the car, and when I want to have a copper layer or something like this inside my CFR container, according to the rules, I have to put so much aluminum inside that I can make an aluminum container from the beginning.
So let's start with the last question. What's the best way to attach the segments to the internal walls with bolts and make it a drawing with
Yeah, so we've talked about it before. This is basically the age-old question between mechanical and electrical scrutineers. But if I draw here like the cross section of your container, you have like external walls and you have an internal wall here. So that is the internal wall. And from my point of view, from a mechanical perspective, if you have your cell stack like this, with your cells up to here, Then you have a bit of your cell stack frame, which goes upwards of that. On that part here, you can add bolts, which hold the whole thing together.
So it's also that's a very good solution to.
And from my point of view, you can also use like captive knots on the inside and make the bolts from the outside.
Yeah, I have to be a little bit careful, but yeah, it's possible.
If it's well insulated,
No, it's fucking very wrong.
yeah. But then of course you can make the bolts go in and out from the outside. And the next part, more safer to work on it.
You have to lock everything. Maybe we could have locking. I think it would be a little bit hard here, but possible.
Okay, thank you all and Koki for your presentation and answers. I think we make a little break again and you can look forward to a presentation from our colleague Heike Adler on how to lock that. Cool. So alles abgesteckt, ja. Wie haben wir das jetzt ausprobiert bezüglich how do we check that with the connection?
We already checked.